Hey guys, welcome back to chapter 15. So, with the remainder of this chapter, what we're going to be doing is calculating a series of problems associated with equilibrium concentrations and that value for the equilibrium constant K. So, there are endless ways that we can ask questions in this equilibrium chapter and endless possibilities for things to solve for. These are going to be important skills to have because we're going to learn them in this chapter. Then we're going to apply them to situations when we get to the acid and base chapter. So here's where we're laying the foundation. I've tried to organize the three different types of problems that we will encounter. And of course, inside of each of these three categories, there's all kinds of different little nuances, little twists that we can put in. But I try to do my best to organize our thoughts and to categorize these into one of three different categories. So the first category is the easiest category. It's the one we're going to talk about in this slideshow. So it's determining equilibrium concentrations of one unknown when we know Kc. So really the key here is one unknown. So either we're given all the equilibriums and we solve for Kc, or we're given Kc and most of the equilibriums and we have to solve for one equilibrium concentration. So really the key for these are just solving for one unknown piece. Then we get a little bit more difficult. We determine equilibrium concentrations and the value of Kc when we know initial concentrations and we know only one equilibrium. So we do have a bit of knowledge here for this guy. We know initials, we know some of the equilibriums, but still a lot of the pieces of the puzzle that we have to fill in. The good news about this section is we can fill in most of the pieces of the puzzle and then just simply plug and chug our way through it. So that's really the green one is just filling in the puzzle and then plugging through it. The last category is the most difficult. So this is going to be where we go back and rely on a lot of our old school algebra skills. And don't worry, we'll review those together. But we're going to go way back to old school algebra rules here. And they're going to help us to determine the equilibrium concentrations. So what will we know? Well, we'll know Kc and we'll know only the initial concentrations. So while this is the hardest of the three categories, it's also probably the most realistic of the three categories. So we can manipulate initial concentrations pretty easily. Sometimes calculating the final concentrations is a little bit trickier. So how do you isolate just one of the molecules to get the final concentration, the equilibrium concentration? So certainly the most difficult, but also the most realistic. For this chapter, so I split this chapter up into 15A, 15B. For 15A, you will be responsible just for the first bullet point here. So that's what this video is going to talk about. I want you to really focus on those for this half of the chapter. And then when we open up the second half of the chapter in the following week, we're going to spend the rest of the time on the green category and the red category. That's how difficult they are. So let's dive into the blue category, the easiest one, where we're solving for one unknown piece. So determine the equilibrium concentrations of one unknown if we know Kc. So here is our equation. In an equilibrium mixture, so we reach in once it's reached equilibrium, and we determine that COF2 has a concentration of 0.255. CF4 has an equilibrium concentration of 0.118. And we want to know what is the equilibrium concentration of carbon dioxide. All right, so the first thing we're going to do here is just write our equation. So equation for K, concentration of our products. divided by our concentration of reactants. Okay. So from here, I'm just going to plug in what I know, and that hopefully will allude to the one unknown, the one thing I need to solve for. So I do have my value for K, so K equals 2. The next thing I see is carbon dioxide. Well, that's what we're solving for. We don't know that. So I'm going to leave that in the equation as a variable. CF4, so we know the concentration of CF4, it's 0.118. And then on the bottom, we have our reactant, so that's going to be 0.255. From here, it's just algebra. You can go attack this a few different ways. I'm just going to attack it this way. It's not necessarily the right way or the only way, but it's the way that makes sense in my brain. So the first thing I'm going to do is get rid of this fraction. So I'm going to multiply by 0.255. So that's on top, that's on bottom. It cancels. Whatever I do to the right side, I also have to do to the left side. So multiply by 0.255. Okay. All right, so clean up the left-hand side there. So 0.255 times 2 equals, we've got 0.51. And then now we're left with carbon dioxide times 0.118. Okay. So you get carbon dioxide by itself, I just divide by the 0.118. So that cancels. Whatever I do to the right side, I also have to do to the left. So divide by 0.118. So the concentration of CO2 at equilibrium is 0.51 divided by 0.118, and it is 4.32 molar. Okay. Cool thing about these problems is we can check our work pretty easily. So if I want to check my work, I can just plug it back into the equation. So carbon dioxide is 4.32. I'm going to other way. I'm going to multiply that by CF4 right here. So CF4 is 118. And then I'm going to divide by the reactant, which is 0.255. And that should equal something very close to 2. So I'm going to take 4.32 times 0.118 divided by 0.255, and my calculator spits out 1.999. So checked my answer, and it is in fact correct. I think the slideshow walked you through this a little bit slower than I did. So there's those. Okay. These are easy, straightforward problems. So the different ways that I can mix it up is I could ask really for any of these three concentrations. So I could ask for any of these guys. I could give you, we've actually done this already, but I could give you all of these and ask you to solve for KC. The big thing here is one unknown that you have to solve for. So that's it for 15A. I hope you guys found this helpful.